Okay, here I have a circuit, and let's just explain what's going on. Let's follow it out of the positive terminal of the battery. We go from plus into this DMM measuring milliamps. So we see right now we have about 120 milliamps. That matches up pretty well with this rough estimate from the device itself. So about 120 milliamps. Then we go from there. We come into this circuit right here at line 24. At line 24, you can see I've got a 32.6 and a 46.3 in parallel. They spit out here at row 31. Then there's a jumper cable connecting to row 36. There I have a 55.2 and a 21.7. Then from there, we spit out on this jumper wire and come back to home. It's right there. Just so we get some extra sig figs, all I'm doing here is putting a voltmeter. So again, this one is a different DMM, but we're measuring DC volts here. Sorry for all the different types of voltmeters. It's probably good practice to learn how to read all the different dials too. Okay. And so this matches up pretty well with what we expect. It says 5.4, but it looks like it's more like 5.5. Finally, I have one more DMM here. That's what this purple tape for. Sorry I lost my kickback. I'm going to measure voltage here as well. Is that pretty good?
Yeah.
Or back?
That's fine, just like that.
All right, and so now I'm just going to go around and measure some of these resistors, and hopefully you can observe these measurements. The goal is hopefully to notice that when you simulate this, you probably don't get the same answers as the real world. Okay, so just checking this one. Sorry, there we go. Oh, whoops, I got it flipped. But it was about 2.3, I think. Let me get in there. There we go. 2.2 volts. That was across the 32.6. So now across the 46.3, we get 2.4 volts. Across the 21, actually let's do the 55. Across the 55, we get 1.8 volts. And across this 21.7, we get 1.84 volts. All right.